The next lesson in the algebra review series is solving systems of equations. I'll be able to find the intersection of two lines by solving the system of equations. And that is what we're doing when we're solving the system of equations. We're finding a point of intersection. And I actually probably should have put in here, I'll be able to find the point of intersection of two lines, and that point being an x, comma, y. And we sometimes forget that. But we'll talk about when we get into the geometry of stuff that two lines always intersect in one point, and that location on a coordinate grid or in space is given by x, comma, y. The first method we're going to talk about is graphing. Step one, graph both equations on the same coordinate plane, estimate the point of intersection, and check your estimate by substituting coordinate values back into both of the original equations. So we're going to graph them on the same coordinate grid. You could use standard form if you're comfortable with that, but if you want to solve it in slope-intercept form, then you have your slope and your y-intercept that are easy for you to graph. Estimate the point of intersection. We talk about estimate because that x, comma, y might not be nice integers on a crosshair, and that what makes graphing maybe sometimes not the best method. Check your estimate by substituting the coordinate values back in. So we're going to take that x and y and we're going to plug them back into the original formula to make sure that both sides of the equal sign are the same or are equal. So here are two equations. So let's talk about the top one. 3x minus y is equal to 2. Let's solve that for y. So I am going to subtract 3x from both sides. That leaves me with a negative y is equal to negative 3x plus 2. But I want just y because I want it in slope-intercept form, which is y equals mx plus b. So I'm going to divide both sides by a negative 1 because I want to make that y positive. So that is going to be y is equal to a negative y divided by a negative 1 is a positive y. Is equal to a negative 3 divided by a negative 1 is a positive 3x, and a positive 2 divided by a negative 1 is a negative 2. So now I can graph that equation. So my slope-intercept, or my y-intercept is going to be negative 2, and my slope is going to be a positive 3. So that's going to be up 3, 1, 2, 3, and to the right 1. And I can keep going. I can plot as many points as I possibly can. I could also go in the opposite direction because two negatives equal positive. So I could go negative direction down and to the left negative direction and have another point right there. Now, you should be using a straight edge to draw your graph. I'm going to use one too, even though I'm on my computer. So I just have a long index card that I'm going to use to graph this. And that's not the best line. You should do better than what I just did. And now I'm going to do the other equation. X plus y is equal to negative 6. So I want to bring the x to the other side. So in this case here, my slope is negative 1 and my y-intercept is negative 6. And if I go down one and to the left one, that's typically how we do the slope. But we have to remember we can go in the opposite direction. So we go up one and to the right one, or excuse me, to the left one, and that's still a negative slope. Up and to the left is still a negative slope. And I'm going to use my straight edge again to draw a straight line. And I can see that the point where the two lines intersect is this right here, which is negative 1, comma, negative 5. That point of intersection between two lines is going to be really important for us this year. And let's just check to make sure that they fit in there, that point works out. So if I have 3 times negative 1, which is my x value, minus my y value, which is negative 5, Does that equal 2? And I can see that it does. So it works in that equation. And let's just check the second equation. Oops. So my x value is -1. And my y value is -5. And does that equal -6? We know that -1 plus -5 is -6. So yes, it does check out. So the next method is the method of substitution. So our steps are solve either equation for x or y. And it doesn't matter. We always think we have to solve it for y, but if x has a coefficient of 1 or -1, it's going to be easy to work with that one too. Step 2, substitute y or x into the other equation. So if you solve for y, you're going to substitute that for y in the other equation and vice versa if you're working with x's. And then once we'll solve that for the remaining variable. And then step 3, substitute the value from step 2 back into the equation from step 1 to get the other variable. Because remember, in the end, we need an x and a y value. Because when we solve a system of equations, we are looking for a point of intersection between two lines. Really important to continue to remember that. So here are two equations, and you can see that the first equation, 5x plus y, you have the coefficient of y is a 1. So that equation right there will be the one that is easier for us to solve for just a single variable. So if we have 5x plus y is equal to 12, I'm going to subtract 5x from both sides. And I'll get y is equal to -5x plus 12. And you could do 12 minus 5x. But when I solve for y, I always put it in that slope-intercept form. It's just habit. It's a useful way usually to use the y, something y equals. And then what I can do with this now is that this whole thing right here is the value for y. So I can plug that into the second equation for y. So I'm going to have 2x, I don't have an x value, minus 3 times that value right there, which is the y value, -5x plus 12. And that's going to be equal to -2. So now I just have one variable, x. I have a couple of them, but there's only one variable in this equation, which is x. And now I can solve that equation for x. So pause the video and solve that equation for x. So I've solved the equation for x, and you should have too, and you should have come out with x is equal to -2, or excuse me, x is equal to +2. If you didn't, check your steps against mine just to make sure, but we should be solving for x pretty confidently on our own at this point here. So I'm not finished because I need an x comma y. I need that point of intersection between two lines, that point of intersection. So I'm going to take that x value and I'm going to plug it back up into my equation that I've already solved for y to get the value of y. So I have -5x plus 12. Well, I have a value for x, 5 times 2 plus 12. Y is also going to be 2, and that's just a coincidence in this problem. So my point of intersection is going to be 2, 2. Now, if you plug those back in to those two equations, do they work? Let's just check. 5 times 2 plus 2, that's 10 plus 2. Does that equal 12? Yes. And then the second one, that's going to be 4 minus 6. Does 4 minus 6 equal -2? Yes, it does. So that works out. The third method is elimination. Use elimination when neither of your equations can be solved for x or for y so that you can use substitution, and that happens sometimes. So our steps are, we're going to multiply each equation by a suitable number so that the two equations have the same leading coefficient. Actually, same leading coefficient, but opposites. We want them to be opposites, meaning we want something like 2x and negative 2x. What happens when I have a 2x and negative 2x? Those equal 0. So we want to eliminate them by making them something equal to 0. Subtract the second equation from the first and solve for the new equation for remaining variables. So if I have that, I'm only going to have one variable left. Substitute the value from step 2 into the equation from step 1 and solve for the other variable. You should be pausing these and writing these down just to make sure you have them. So solve system of equations. If we look at these two equations here, 3x plus 7y is equal to 15. That does not have a coefficient of x or y that is 1. So we can't use substitution. We could, but it'd be messy. And then 5x plus 2y, neither is equal to negative 4. Neither one of those is a coefficient of 1. So again, we could solve for x or y, but it just might be a little messy and have some fractions we might not want to work with. So it doesn't matter if you want to eliminate x or if you want to eliminate y, but we want to make sure that we do that. So I kind of put a bracket around it and I say, well, if I multiply the top by 5 and I multiply the bottom by negative 3, then I'm going to have on top 15x plus 35y is equal to 75. And you have to remember that that 5 has to get distributed to the entire equation. Not just the left-hand side, to all of it. And I'm going to do the same thing with that negative 3. Distribute it. So that's negative 15x minus 6y is equal to negative 3 times a negative 4 is a positive 12. So now I can subtract the second equation from the first equation, and what happens here is my 15x and my negative 15x cancel each other out because 15x minus 15x is going to be 0. And now I'm just dealing with y's. My x's have been eliminated. So 35 minus 6 is 29y. And 75 plus 12. So really we're not subtracting, we're just combining like terms. 75 plus 12 is 87. And we divide both sides by 29. We're going to get y is equal to 3. But again, I'm not finished. We need an x and a y. We need a point of intersection. So I have my y value. So now plug that back into one of your original equations, and it doesn't matter. I mean, if you could plug it back into either, and you should get the same answer. So I'm just going to do the top one. So I have 3x plus 7y is equal to 15. I have a y value, so I'm going to take this y value and plug it in, substitute it. 3x plus 7 times 3 equals 15. And now I only have one variable, and I can solve for x. So x is equal to negative 2. So my point of intersection and my answer on this is going to be negative 2. That's a bad 2. comma, 3. Make sure you're putting it in the right order. Now, if I plug that into that second equation, it should work. So if I were to put 3 into this other equation, let's just check. Am I going to get the same answer? Yes, I get a -2. So it works for both equations. So my final answer, my point of intersection, when I solve the system of equations, is -2, comma 3. So those are the 3 methods of solving system of equations: graphing, which shouldn't be used often, substitution, and elimination. And they all warrant themselves for times that they should be used.